At this point, check engine lights in Volkswagen are synonymous. It just means the engine's working, right? All jokes aside, check engine lights should not be left unchecked. I'll be using the OBD11 dongle. This thing is the best bang for your buck on a Volkswagen specific scan tool. It lets you scan every module in the vehicle, see codes, live data, even mess with some coding. Just enough power to be dangerous. Okay, we have a couple fault codes stored in the engine control module. We will be focusing on the Bank 1 and Bank 2 mixture adaptation fault codes. Both of these codes set when the engine is running lean. Lean and rich are common terms when talking about the air-to-fuel mixture inside the engine. Lean happens when there is more air in the system than required. Rich happens when there is more fuel in the system than required. Both conditions have bad consequences if left unchecked. We will be focusing on the lean condition. With the OBD11, we can check some live data to help narrow down where the engine is getting extra air from. We'll start with checking the air-fuel mixture at the oxygen sensors. In a Volkswagen, these readings are listed as lambda. Lambda is a math term used to describe the perfect air-fuel ratio as a single value. A perfect air-fuel ratio is 14.7 to 1. 14.7 parts of air to 1 part of fuel. 14.7 to 1 is equal to lambda 1. Any higher than 14.7 is considered lean. Any less than 14.7 is considered rich. In lambda terms, anything less than 1 is rich, and anything greater to 1 is lean. We will select the lambda control mixture adaptation data block. In it, we can see a whole bunch of percentages. Volkswagen takes this single lambda value and converts it into a percentage. 1 equals 0%. A positive percentage is the engine trying to add fuel, meaning the engine is running lean. A negative percentage is the engine trying to take away fuel, meaning the engine is running rich. While our Bank 1 and Bank 2 idle readings are technically within specification, they're still higher than they should be. If we check the engine speed at idle, we can see it is on the high side of specification. What this is telling me is there is an air leak somewhere in the engine, but it is small and not throwing a whole lot of stuff out of whack. In the engine bay, with the engine covers removed and the engine running, visually check all the vacuum lines. Volkswagen loves this hardline stuff, and as it ages, it is more prone to cracking. After the visual check, we can break out my favorite diagnostic tool, the Brake Clean Spray Check. Spray parts of the engine you suspect may be leaking air. If that part is leaking air, the engine will rev up slightly because brake clean is combustible. I found my leak at the back side of the engine, the PCV valve to be specific. The engine revs up slightly when the PCV is sprayed. What is a PCV valve? Basically, the engine is a giant air pump. Some of that pressurized air slips by the piston rings and into the bottom of the engine. The PCV valve takes this pressure and lets it out of the engine block and back into the intake. This process prevents pressure from building up and blowing out the oil seals. Okay, let's shut the engine off and get to work replacing this thing. Start by removing the PCV crossover tube to give more room to work. Remove the clamp from the upper hose. A 90-degree pick works well to pry open the clamp and remove it. Either clamp on the lower hose could be removed, but I found that the lower clamp is easier to reach. With the clamps removed, pull the PCV valve from the hoses. The 90 elbow hose will need to be transferred to the new valve. Before we install the new one, I'm curious to see how this valve works. Time to tear the old one apart. Well, I'm no expert, but it looks like the spring keeps the orange diaphragm shut until there is enough crankcase pressure to overcome it, allowing the pressure to escape into the intake. Closer inspection of this diaphragm reveals some cracks. This would let the outside air into the system, causing our check engine light to turn on. These old clamps can be reused. It helps to have a CV boot clamp tool. If If you don't want to deal with reusing the clamp, a regular hose clamp will work just fine. Install the new valve in clamps, then reinstall the crossover pipe. Start the engine and do another spray check. The engine should not rev up. Clear the fault codes and do a test drive with a couple key cycles. There you have it. I'll put a link down below to the parts and the CV boot tool. Thanks for watching.